So we will get the equation as d square y by dt square plus lambda y equal to 0. The auxiliary equation will be m square plus lambda equal to 0. Now when you find the roots will be m equal to plus or minus root of minus lambda. Ini lambda greater than 0 you will have m equal to plus or minus root lambda I. So we will get complex roots. So therefore solution is going to be y equal to c1 cos root lambda t plus c2 sin root lambda t. Now we started with the substitution x equal to tan t. So here t will be tan inverse of x. So our solution is y equal to c1 cos root lambda tan inverse of x plus c2 sin root lambda tan inverse of x. Now use the boundary conditions. So you have y at 0 equal to 0. So tan inverse of 0, 0 sin term 0 cos 0 will be 1. So you will get c1 equal to 0. So c1 is 0. For the second condition, when y of 1 is 0, you will get c2 sin root lambda tan inverse of 1 equal to 0. So c2 0 pattilla. For non-trivial solution, C2 must be not equal to 0. So, remaining sin in the term 0. So, sin root lambda pi by 4 will be equal to 0. So, that implies root lambda pi by 4 will be equal to n pi. So, we will get n equal to root lambda by 4. So, therefore, lambda will be equal to 16n square. So, where n will be equal to 1, 2, 3, etc. So these are the corresponding, characteristic values, and the corresponding characteristic function will be for c1 0 ana. So y will be c2 sin root lambda tan inverse of x. That will be the solution. So you can write it as y equal to cn sin 4n tan inverse of x. So that is the required characteristic functions. Lambda less than 0 in the case. So once you use the transformation x equal to tan t, this is the differential equation you are getting. So auxiliary equation will be m square plus lambda equal to 0. So now m will be equal to plus or minus root of minus lambda. Lambda is less than 0. So let me put alpha equal to root of minus lambda. So the roots are real and distinct. So solution is going to be y equal to c1 e raised to alpha t plus c2 e raised to minus alpha t. T replace here. So you will get y equal to c1 e raised to alpha tan inverse of x plus c2 e raised to minus alpha tan inverse of x. Now let us use the conditions. So y at 0 equal to 0 edukumbo, you will get c1 the e raised to 0 varum, രണ്ടിടത്തും e raised to 0 ആവും. So c1 plus c2 equal to 0 varum. Now y of 1 equal to 0 will give c1 e raised to alpha pi by 4 plus c2 e raised to minus alpha pi by 4 equal to 0. Now for non-trivial solution, determinant must be equal to 0. Determinant equal to 0 alpha 0 avanam. So therefore alpha cannot be 0 since lambda is not equal to 0. So therefore there will be no non-trivial solution. So the characteristic values will be lambda equal to 16n square, and the characteristic functions will be y equal to cn sin 4n tan inverse of x. So and I want you to do one more problem. So that is d by dx of 1 by 3x square plus 1 dy by dx plus lambda 3x square plus 1 y equal to 0. So these are the conditions. So here നമ്മൾ ഈ പ്രോബ്ലം ചെയ്ത പോലെ തന്നെ here ഇവിടെ നമ്മൾ x equal to tan t ആണ് substitution എടുത്ത്. So here we need to use a substitution t equal to x cube plus x. So using the substitution, so try to solve this problem. Okay. now let us look at one theorem. അപ്പോൾ നമ്മളിപ്പോൾ കുറേ problems solve ചെയ്തു, stum Lowry problems. So from all these problems we arrive at a few conclusions. So we will state that as a theorem, just the theorem. അത് നിങ്ങൾ അറിഞ്ഞിരിക്കുക. stum Lowry problemത്തിന്റെ characteristic valuesന്റെയും characteristic functionsന്റെയും പ്രത്യേകത എന്താണ്. So here we have the problem. So consider the stum Lowry problem consisting of the differential equation d by dx of p of x dy by dx plus q of x plus lambda r of x y equal to 0. So p, q and r are real functions and p has continuous derivative and q and r are continuous. So here p greater than 0, r greater than 0 for all x in the interval a to b. And lambda is a parameter which is independent of x. So this is how we defined our stum Lowry problem. And you have two boundary conditions. So that is a1 of ya plus a2 of y dash of a equal to 0. Then b1 of ya plus b2 of y dash b equal to 0. So this was our stum Lowry problem. And we will look at the three conclusions we obtained from the stum Lowry problem. So the first conclusion is regarding the characteristic values. So namukku different lambda values kittum. Now when you look at the values of lambda, the values ഇപ്പം എപ്പോഴും infinite number of characteristic values ഉണ്ടാവും. ഇനി അതുപോലെ അത് എപ്പോഴും monotonically increasing ആയിരിക്കും and the characteristic values tends to infinity as n approaches to infinity. നമ്മളിപ്പോൾ ചെയ്ത എല്ലാ പ്രോബ്ലംസും നിങ്ങൾ പ്രോബ്ലംസ് എടുത്ത് നോക്കിയാൽ മതി, അവിടെ എല്ലാം characteristic values ഈ conditions satisfy ചെയ്യും. So there exists an infinite number of characteristic values lambda n of the given problem, and these characteristic values can be arranged in a monotonic increasing sequence. So you will have in the form lambda 1 less than lambda 2 less than lambda 3 etc. And lambda n goes to infinity as n tends to infinity. So that is the first conclusion from the characteristic values. And the second conclusion is corresponding to each characteristic value lambda n, there exists a one parameter family of characteristic functions phi n, and each of these characteristic functions is defined on the interval a less than or equal to x less than or equal to b, and any two characteristic functions corresponding to the same characteristic values are non-zero constant multiples of each other. അതും നമുക്ക് എല്ലാ സൊല്യൂഷൻസിനും കാണാൻ പറ്റും. So corresponding to characteristic value lambda n, you are getting a one parameter family of characteristic function. അപ്പം നമ്മൾ ഫോർ എക്സാമ്പിൾ ഇതിൻ്റെ അകത്ത് നോക്കിക്കഴിഞ്ഞാൽ, so corresponding to lambda equal to n square by 4. So you are getting a one parameter family of curves here. So corresponding to n equal to 1 എടുക്കുകയാണെങ്കിൽ you will get y equal to c1 cos ln x by 2. So there is only one arbitrary constant c1 in it. Okay. അതുപോലെ ഇവിടെ n equal to 2 എടുക്കുമ്പോൾ c2 cos ln x വരും. n equal to 3 എടുക്കുമ്പോൾ c3 cos 3 ln x. So here you will have corresponding to each characteristic value. So you will get a characteristic function which is a one parameter family of curves. ഇനി അതുപോലെ നമ്മൾ സെയിം characteristic value എടുക്കുമ്പോൾ നമുക്ക് ഇതിൻ്റെ തന്നെ constant multiples ആയിരിക്കും വരിക. So here c1 keeps on changing. So as you take the same characteristic value, so the solutions will be, characteristic functions will be multiples of one another. Okay. So that is the second conclusion. And the third conclusion is each characteristic function phi n corresponding to the characteristic value lambda n, where n equal to 1 to 3 etc. has exactly n minus 1 roots in the open interval a less than or equal to x less than or equal to b. So നമ്മൾ ഒരു peculiar characteristic function phi of n എടുത്തു കഴിഞ്ഞാൽ corresponding to particular value of n, that will have exactly n minus 1 roots. So let us see an example. Okay. So this problem നമ്മൾ ഏറ്റവും ആദ്യം ചെയ്ത problem ആണ്. ആ പ്രോബ്ലത്തിൽ so the characteristic values were lambda n equal to n square and characteristic function നമുക്ക് വന്നത് cn sin nx. Now sin nx equal to 0. So we need to find what are the different roots of cn sin nx. So the roots will be given by sin nx equal to 0. Ni sin nx 0 ആണെങ്കിൽ nx must be equal to k pi. Okay. So where k is some integer, and now x will be equal to k pi by n. So here k will take the values. So in general k can be 0, plus or minus 1, plus or minus 2, etc. ഇനി നമ്മുടെ problem എന്ന് പറയുന്നത്, okay, so we need to show that in the open interval a less than or equal to x less than or equal to b, there will be exactly n minus 1 zeros. ഇനി ഇവിടെ a b എന്ന് പറയുന്നത് 0 to pi ആണ്. So you will have 0 less than x less than pi. So if my roots have to be in the interval 0 to pi, അപ്പോൾ k ക്ക് 0 ആവാൻ പറ്റില്ല. ഇനി 0 to pi വരണമെങ്കിൽ നമ്മൾ എടുക്കുന്ന k values എല്ലാം പോസിറ്റീവ് ആവണം. So k can be 1 because pi by n will lie in the interval 0 to pi. ഇനി k can be 2, 3, 4 etc. up to n minus 1. കാരണം n വരുമ്പം തുടങ്ങി k യുടെ വാല്യൂ x ന്റെ വാല്യൂ pi ആവും. That is not in this interval. So the possible roots will be pi by n, 2 pi by n, 3 pi by n, etc. n minus pi by n. So therefore there will be exactly n minus 1 roots. So the zeros which lie in the open interval 0 less than x less than pi are precisely for those precisely for k equal to 1 to 3 etc. n minus 1. So therefore for each characteristic function cn sin nx there will be precisely n minus 1 zeros in the open interval. So these are the three conclusions. അപ്പം lambda values monotonic increasing ആയിരിക്കും. അതുപോലെ they will converge to, they diverge to infinity as n approaches to infinity. Then you are getting characteristic function as one parameter family of curves, and നമ്മൾ characteristic function the zeros നോക്കുമ്പോൾ in the interval a less than x less than b there will be precisely n minus 1 zeros. So those are the different conclusions we obtained from the Sturm-Liouville problem. Okay. Okay, so we'll begin the next session in the coming class. Thank you.